So, chemistry is the study of matter. The scientific method is abbreviated HOTEL, and that stands for hypothesis, observation, theory, experiment, and law. There are three states of matter: solid, liquid, and gas. Solid has a definite shape and volume. It's made of particles held close together and rigidly in place. Liquid has a definite volume, but an indefinite variable shape. Its particles are held close together and move relative to each other. Liquid is fluid and may or may not fill a container completely. Gas has no definite volume or shape. It takes the shape and volume of the container. It's made of particles that are separated from each other by large distances and move very fast. They have high kinetic energy. Matter has subcategories based on composition and properties. Matter can be heterogeneous or homogeneous. Homogeneous can be pure substances or a solution. Pure substances can be compounds or elements. Compounds and elements can be separated or combined chemically. Compounds are molecular or ionic. Elements cannot be divided chemically or physically. Physical separation methods can be mechanical, such as sand and iron filings, filtration, such as sand and water, extraction, such as washing clothes and decaffeinating coffee, distillation, such as gasoline from crude oil, or chromatography, chlorophyll pigments in leaves. Matter's physical properties are characteristics that can be measured or observed without changing the basic identity of the matter. Examples of physical properties are state, size, mass, volume, color, odor, melting point, boiling point, density, and solubility, as well as magnetism. In chemical properties, there must be a chemical change, a chemical reaction. Examples are flammability, corrosiveness, oxidizing reducing power, explosiveness. Physical changes to matter include melting, freezing, boiling and condensing, subliming and depositing, dissolving. Chemical changes are rusting, burning, combustion, formation of a precipitate, gas forming, acid-base neutralization, displacement reactions, color changing, heat absorbed evolved. Intensive properties do not depend on the amount of matter, while extensive properties do. Density is an intensive property. The formula for density is mass in grams over volume in centimeters cubed or milliliters. It is useful to know that the density of H2O is 1 gram per centimeter cubed of pure water at 4 degrees Celsius. Therefore, anything above sinks in water. SI units contain prefixes in front of the unit that either increase or decrease the size of that unit. The SI base unit for length is the meter. If you're trying to find the mass, use the kilogram. For time, use seconds. Temperature is the Kelvin. The amount of substance are moles. Electric current is measured in amperes, and luminous intensity is the candela. The prefix kilo increases your unit by 3 decimal places. Mega increases your unit by 6 decimal places. Giga increases by 9, and tera increases by 12. Prefixes that decrease the size of your unit are deci, which decreases by 1 decimal place. Centi decreases by 2. Milli decreases by 3. Micro by 6. Nano by 9. Pico by 12. And femto is the smallest and decreases your unit by 15 decimal places. There are 2.2 pounds in a kilogram, and you can write this in a conversion factor, which is a ratio. You put 1 kilogram over 2.2 pounds, or 2.2 pounds over 1 kilogram. When you're using conversion factors with squared units, make sure to square your values. Accuracy means how close your measurements are to the actual value, while precision means how close your values are to one another when repeating trials. When using a ruler for measurements, you want to estimate your last digit. For example, when a ruler has markings of 0.1 centimeter, you want to estimate to 0.01 centimeters. Your significant figures are all non-zero numbers, as well as zeros at the end of your number, except if they're used as a placeholder in a large number without a decimal point. Zeros at the left side of your number are not significant, however zeros between your number values are. Exact numbers have unlimited significant figure. These are definitions, such as 12 inches and 1 foot. These can also be direct counts, such as 262 students in a classroom. And also, numbers that are part of an equation, such as d equals 2r. All of these have unlimited number of significant figures. When adding or subtracting, look for the value with the fewest digits after the decimal. Your answer should have as many digits after the decimal as the number in calculation with the fewest. However, in multiplication, look for the value with the fewest significant figures. Your answer should have as many significant figures as this value. The difference between subtraction and addition and multiplication and division is that in subtraction and addition you are looking at the decimal places, while in multiplication and division you're looking at the number of significant figures. So in temperature, thermal energy flows from the object with higher temperature to the lower temperature. Temperature can be measured in Kelvin, Celsius, or Fahrenheit. 0 Celsius is the freezing point of water, while 100 Celsius is the boiling point. Kelvin is Celsius plus 273.15. Fahrenheit is 1.8 Celsius plus 32. So, Dalton's atomic theory states that all matter are composed of tiny, indivisible particles called atoms. The law of conservation of mass says that atoms are not created or destroyed, but can be rearranged in a chemical reaction. Molecular compounds are held together by covalent bonds, while ionic compounds are held together by opposite charges, such as the positive sodium cation and the chlorine anion. Rutherford's gold foil experiment proved that atoms are mostly empty space. The small, dense central core is the nucleus composed of protons and neutrons. While neutrons are neutral and have no charge, electrons have a -1 charge and protons have a +1 charge. An element's atomic number is the number of protons. Subtract the atomic number from the atomic mass and you have the number of neutrons. In a neutral element, the number of electrons equals the number of protons. Adding an electron to a neutral element gives it a -1 charge. A neutral element that's lost 1 electron has a +1 charge. An element always has the same number of protons, but can have a different number of neutrons depending on the isotope. Different isotopes have different numbers of neutrons, therefore have a different mass. The abundance of isotopes is measured experimentally using a mass spectrometer. If you want to calculate the mass, of an element with many different isotopes, you have to calculate the average of each isotope mass. For every isotope, you multiply the mass by the abundance, and then add all of the different isotopes together to get the final mass. 1 mole is a large number of atoms. This number of atoms is known as Avogadro's number, and it is 6.022 times 10 to the 23. The molar mass is grams per mole, and you can find it using your periodic table. Groups are the columns on the periodic table. Your group 1A is the alkali metals, while group 2A is alkaline earth metals. Group 8A are your noble gases, and group 7A are your halogens. Your chalcogens are group 6A, and your pnictogens are group 5A. Phosphor, sulfur, and selenium are polyatomic. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are diatomic. Elements in these same groups are similar to each other. Metals solid at room temperature have luster, are malleable, and ductile. The photoelectric effect of metals means metals emit electrons due to light. The thermionic effect means metals emit electrons due to heat. Metals are good thermal and electrical conductors. They readily lose electrons to form cations. Nonmetals readily gain electrons to form anions. Allotropes are different forms of elements, such as diamond, graphite, and buckyballs, which are forms of carbon. Group 1A metals lose 1 electron to produce a monopositive ion. Metals in group 2A lose 2 electrons to produce ions that are positive 2. Nonmetals gain electrons and form ions with a negative charge, equal to 8 minus the group number of the element. So ionic compounds are bound together by ionic bonds between positive cations and negative anions. Ionic compounds have high melting and boiling points, and they're solid at room temperature. They have no net charge. Some common main group metal ions are lithium, sodium, potassium, magnesium, calcium, barium, and aluminum. Some common nonmetal ions are nitride, phosphide, oxide, sulfide, fluoride, chloride, bromide, and iodide, and hydride. When naming transition metal cations, name the element and put the charge in Roman numerals. Exceptions are silver, which always forms a +1 charge cation, zinc, which forms +2, and cadmium, which also forms +2. Polyatomic ions are groups of atoms and have an overall positive or negative charge. Our polyatomic ions are ammonium, hydronium, hydroxide, azide, carbonate, cyanide, acetate, oxalate, nitrate, nitrite, phosphate, phosphite, sulfate, and sulfite. You can hydrogenate our polyatomic ions to form hydrogen carbonate, also known as bicarbonate, hydrogen sulfate, bisulfate, hydrogen sulfite, bisulfite, hydrogen phosphate, dihydrogen phosphate, hydrogen sulfide. When naming ionic compounds, make sure to name the cation first and then name the anion. Some notable examples of our ionic compounds with polyatomic ions are sodium nitrate, potassium sulfate, iron 3 bicarbonate, iron 3 hydrogen carbonate, and ammonium phosphite. Halogens, except fluorine, form 4 oxyanions. Our ion ending in 8 has 3 oxygens. 1 less oxygen and we have ite. 2 less and we have hypo prefix and ite suffix. 1 more than the suffix ate, then we have per prefix and ate as the suffix. Oppositely charged ions are attracted to one another by electrostatic forces which are governed by Coulomb's law. Coulomb's law tells us as ion charge increases, the attractive force increases. But as the distance between ions increases, the attractive force decreases. When naming binary acids, we use the prefix hydro and the suffix ic, and then follow it by acid. For example, hydroanionic acid. Our oxo acids have a hydrogen, oxygen, and another non-metallic element. When our anion has the suffix ate, our acid suffix will be ic, while if we have the suffix ite, our acid suffix will be us. When naming molecular compounds with 2 nonmetals, we follow by the suffix "ide". Our prefix denotes the number of atoms. For example, for 2 atoms we use di, 3 is tri, 4 is tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Hydrocarbons are compounds that contain only carbon and hydrogen. The simplest are alkanes, and they're followed by the suffix -ane. The formula mass is the sum of atomic masses of all the atoms in our chemical formula measured in AMU, while our molar mass is measured in grams. Some of our chemical formulas include the empirical formula, which contains the simplest whole number ratio in the compound, the molecular formula, which indicates the elements present and the exact number of atoms of each in a unit of the compound, and we have the structural formula, which denotes a molecular structural information. Hydrates are compounds that contain intact H2O, and we identify them by using the suffix hydrate and a prefix that indicates the number of H2O molecules.